presentation was produced by the Maryland Energy Administration with American Recovery and Reinvestment Act funding. This is webinar number 2 in a series of webinars focused on training design professionals and general contractors as trades in energy code compliance. Today, we will be discussing the information that needs to be included with plan submittals for insulation, air sealing, and duct sealing. The state of Maryland adopted the 2012 IECC as state law in January of 2012. All jurisdictions were required to begin enforcement of the 2012 IECC by July of 2012. This webinar focuses on details needed to comply with state law and the energy code. Builders have identified the lack of energy detail on plans or incorrect energy details on plans as major impediments to compliance with the energy code. Design professionals can make the compliance process easier and more effective by clearly including energy code compliance details on the plans. Air sealing compliance requires a continuous thermal envelope as well as a continuous air barrier. The building envelope includes materials that enclose conditioned space or boundaries between unconditioned and conditioned space. Building best practices indicate that the insulation and air sealing systems should be as closely aligned as possible. Elements need to be present at the roof, walls both above and below grade, slab on grade, at openers and fenestration as well. C402.2 provides the thermal requirements of these items. For open envelope requirements, the table is a quick and simple way to generically know requirements for the project, what is being provided within the project, and what zone we are in. While this is extremely helpful in demonstrating compliance, it is essential that the drawings show all of the graphic information as well. For the we see here, the areas highlight the building thermal envelope. Tracking here are either keynotes that describe each element in detail, or specific notes and leaders indicating what each element or material is. The thermal envelope has a break at the foundation/slab/exterior wall junction. This is continuous and creates a thermal bridge. Violation C402.2.6, which details slab insulation requirements. Detail. These type of thermal breaks that are so small they are unavoidable and are relatively insignificant. We do see at the break between the exterior insulation finish system that rod and sealant are being used to maintain a continuous air barrier. This is only shown here graphically and should be called out via notes as well. Here we're showing a great deal of graphic detail and again lacking in specifying notations. There's a section through an overhead door, steam header, and protected slab-on-grade construction. Let's look at the highlighted header junction in more detail. We see, as indicated by the blue arrows, that there is a break in the thermal envelope again at each of the CMU infill blocks at the steel beam header. They do a job of insulating on the exterior behind CMU infill blocks and at the insulated overhead door, but as we stated, the area that the blue arrows showed the thermal envelope is not continuous due to these gaps. At the slab grade, code requires slab edges be insulated per requirements of the climate zone. In this case, we're in climate zone 4 and an R10 is required for 24 inches with an unheated slab. We see that there is insulation below the slab and the door indicates where our thermal envelope is. The blue arrow again clearly shows there is a thermal break where slab edge insulation is required. Here are examples of compliant and non-compliant slab-on-grade insulation details. Note that each of the compliant examples creates a continuous thermal barrier at the edge of the foundation or on the outside of the foundation wall. Many of these requirements can be called out in the general notes within the documents as well as indicated in the sections. Here, near the top of the section, we see vapor retarding house wrap being used. If that was revised to include being taped and sealed per manufacturer's instructions, clearly indicate to the code official that this is intended as the air barrier. For air at the plate/foundation wall junction, This should be revised to indicate some type of sill seal to be used. The building envelope is required to be durably sealed to prevent air leakage and infiltration. Code states maximum tested air permeability ratings for either materials or assemblies. The material approach is one way to comply. Another is to have the assemblies tested. Another option is to have the whole building tested to determine the air leakage rate of the entire building envelope. The insulation requirements are found in section C403.2.7. All ducts, including all transverse and longitudinal joints and seams, must be sealed in accordance with section 603.9 of the International Mechanical Code, regardless of whether they are inside or outside of conditioned space. Some specific duct sealing requirements vary based on whether they are low, medium, or high pressure ducts, while insulation requirements vary based on the duct location. Instructional compliance with these provisions must be included with the plans. The requirement that is most easily complied with via notes. Including duct sealing details on drawings can be impractical. Here is a set of general notes included within the drawing set. Here is a note stating sealing per SMACNA Seal Class A, which complies with section 603.9 as stated in the Energy Code. Or, alternatively, this literally takes the wording from the code and uses it in the construction documents. It states that ducts, air handlers, and filter boxes shall be sealed per section 603.9 of the IMC. Joining me on this webinar of what needs to be on the plans as it pertains to the 2012 IECC. You can find several other short webinars that address specific aspects of the Energy Code on the website at energy.maryland.gov.